Hello, everyone. This is Francesca Vigliani from Cloud Academy. Thank you for joining us for the last episode of our Pandas Like a Boss webinar series. And of course, thank you for sticking with us all through the series. It's been great to go through this learning journey together. As usual, by now you know the drill. Before introducing our speaker, just a couple of housekeeping announcements. I'd like to remind you that this webinar is being recorded and will be shared with you via email. During the webinar, we will leave time for your questions, so feel free to add them in the chat box and our expert will try to answer them during the final Q&A. Lastly, we hope you had time to set up the environment so that we can get going with the session, but if you have problems, don't worry, you just need to have the data on your Google Drive. Andrea will show you how to read the data from that source. Okay, I'm all done with the announcements, so without further ado, let me introduce you to our data scientist, Andrea Giussani.
Thank you, Francesca. Hello, everybody. It's nice to see so many people even today, and thank you for participating at first. So just a brief introduction of myself. I'm a data scientist here at Cloud Academy, where I mainly focus on development of machine learning algorithms to provide state-of-the-art solutions to improve the quality of our product. You can reach me out on LinkedIn, or you can visit my website for updates on machine learning or Python in general. All the details can be found in the webinar-specific GitHub repository, and the URL was provided in the registration email. And also note that I will upload the final transcript of this live demo as soon as we finish the session. So the agenda goes as follows. We're going to recap a little bit what we did last time, and then we jump into today's topic. So this is the fifth and last episode of our Pandas Like a Boss series. I hope you have enjoyed the previous episodes and where we basically have understood how to perform data analysis with time series data. And we saw in particular three major methods that are worth to mention. Here it's wrong, sorry for that, it's just a typo for the slides are not correct, but we saw three major important methods: the PCT change, the rolling, and the shift method. And we have seen them in action using our stock data frame that you used to work in this webinar series. And we have also understood how to plot those results using Pandas. If you have missed that, don't worry. The webinar is publicly available on the Cloud Academy YouTube channel, and the link is obviously there, but also in the registration email. And so if you're curious, you can just go through your registration email and check that link. Having said that, let's jump into today's topic. And today's webinar is entitled How to Make Your Base Code More Efficient. It's quite a fancy name, but I believe it's one of the most important concepts that I hope you will get at the end of this journey. Since you can write, you can know all functions possible from Pandas, but then if you are not able to write efficient code, and then possibly your code will suffer from efficiency and therefore is not going to be placed in production. So since this is a very important topic, we are going to focus mainly on three classes coming from Pandas, obviously. And those three classes are used actually to make your code efficient, but even when you are trying to loop your code or your app, typically you have to take care of that loop, and therefore we're gonna look at iteritems, iterrows, and itertuples, which are three methods that allows you to perform a loop inside Pandas. And we're going to distinguish the use case of each single function that you see there. We are going to understand the apply which is actually a very nice method inside Pandas. And actually, it applies a function along a specific axis, like rows or columns. And we will appreciate this function since it could save our life in many situations. And we will understand when this happens. And finally, we're going to look at the eval method, which is very useful to perform looping operations in the same fashion as the apply. And we have already seen a member of this family in our first episode of this Pandas Like a Boss series. Do you remember it? If not, don't worry. It was the query method. And the query method, we saw that was a member of that particular family. And today we are going to exploit and understand the eval class, which is a general wrapper that allows us to maximize the efficiency of our code. So having said that, let's recap a little bit the environment we're going to use and the data. So as usual, we're going to use the Google Colab environment to for this webinar to perform all the necessary steps in this session. I have written a README on how to set up a Google Colab notebook if you're not familiar with it. And I assume you have already read and set up it since all instructions were provided before the start of this live session. As for the data, we're going to take into account the byte sharing dataset, which is available online in different repositories. Differently from other webinars, we do not need any physical copy in our local environment, but we are going to read the data directly from the net using, obviously, Pandas. So I hope you got curious on how to perform these operations. So let's get our hands dirty and let's jump into the Colab environment. And you should see something like the one that you see here on my screen. It's a standard notebook inside the Colab environment. And as usual, so typically when we have to read the data from our local drive, we basically have to authenticate the Colab session inside the drive. We don't need that because I just said that we are going to read the data directly from the net. And here, Francesca is going to help me since she's going to post on the chat of this webinar the link that we are going to use. So just copy that URL from the chat, and then we are going to use it in a few seconds to read the data.
Andrea, just to confirm that I've posted the link, so keep an eye out in the chat. You should be able to retrieve it from there.
Yeah, sure. Yeah, that's perfect. Yeah, it looks good. So let's copy. Let's copy it. And so as usual, we're going to actually use Pandas. So we're going to import Pandas as standard convention PD. And we're going to run it. It looks strange here because typically we have to authenticate our Colab in order to read from the drive, but not today. We don't need that operation. So let's start with classical import. And we are going to read the data using the function read CSV that you should be pretty familiar to you at this stage of this learning path. And without any surprise, we're going to actually paste inside the function the link to the basically repository that contains the byte sharing data. And you just need to do that because automatically the read CSV function is going to do the dirty job for you. And with just a simple run, you will get the data on your local machine, or in our case, in the Colab session. Looks great, right? So we now have the data in our repository, in our collab session. If you don't know this dataset, it's quite a popular dataset, and it actually describes the number of bike sharing used in the Washington DC area in a particular time frame. So here we are not taking into account the year, we are just taking into account the month, so basically July, in this dummy here, which is 1. Just to give you physical meaning, this dummy here coincides with the 2010 year, but this is not relevant for our purposes. So it contains some information related to the temperature, the wind speed, and the total count of rents. So given that, what we want to do is actually to perform some operations with that data set using pandas. So suppose that we have to perform some looping operation in that particular data frame. Let me say like this, that we have to check how many rows have the total count greater than, let me say, 850 counts per day. And to do that, we have actually to look into, one possibility is to look into each single row of our data frame and then retain only those records that actually satisfy that particular condition. So given that, we have different possibilities in pandas, and one of that is using the iterrows method. The iterrows method is actually a function that allows you to loop through rows in your dataset. And the syntax is pretty easy because actually you just need to take into account the data frame that we call df, and you basically apply the iterrows function. And typically the iterrows function is actually, can you see my screen actually, guys?
Yes, we can see it.
Okay. So
someone was asking if you could scroll up. I think you already did. So hopefully that will.
Perfect.
Awesome. Thank you, Andrea.
So the iterrows actually, it's a function that returns for each single row, as the help is suggesting, an index and actually the full row data that you are taking into account. And therefore, you actually, if you want to investigate those data, you have actually to access to the index and the raw data using actually the keyword for. And as I said, you access to the index and the full row in your dataset. And the syntax is this one. So you actually, this simple line is going to return two objects, an index row and the data contained in that particular row. So as I said, suppose that you have to loop over your data set, and actually you can ask yourself, well, let me check how many rows has a total count of greater than 850. So we can say, well, if a row in position and the total count is described by this column, CNT, greater than 850, then let me say print the row, okay? Or let me say print the row, total count, and the index, okay? So let's check. We get, it's looping through all the rows, so we get few observations here. And if you pay attention, we are just looping through rows, and therefore here we are not performing any aggregation or any algebraic operation. We're just checking the rows that satisfies those particular Boolean conditions. So this is the iterrows, and the iterrows, it's pretty popular way to do that. And the fact is that the iterrows works iteratively, as the name suggests, by rows. Instead, you can work with respect to columns in Pandas, and the same operation can be actually obtained using another method called iteritems. The iteritems is actually used in two particular situations. When you want to iterate over columns, or when you actually have a Pandas series and not a data frame, and you want actually to perform an iterative loop inside that particular series. So given that, the question is, how can I write the same operation that we saw here with the iterrows with the iteritems? So the syntax is pretty easy. The fact is that we can avoid, since we are not working by rows anymore, we can avoid the specification of the index. And therefore, the syntax goes as follows. You just access to the row, and you apply to the data frame not anymore the iterrows, but the iteritems. And then we basically do the same. So if the row, but now we access not directly to the, let me say, so let me say like this. So if row in position count, okay, is greater than 850, we basically print the row in position count. So basically what I wrote is just the same replication of the previous snippet, but now we don't have anymore the index, and therefore it has been basically fixed and updated with respect to the iteritems. Let's try to see whether it's gonna help us. Yes, so the help, if you pay attention to the help, the iteritems iterate over column name and series pairs. What does it mean? It means that you can actually specify a set, not anymore a set of index, but a set of columns. And for that particular columns, it's gonna return the whole Pandas series. So instead, so basically what does it mean? It means that this particular syntax is wrong for the specification of the iteritems. The iterrows work with respect to rows, and therefore you loop over rows, but with respect to columns. Here you cannot write this anymore, since you are looping through columns. And my suggestion is, well, when you have to apply this to iteritems, you can actually access directly to the column. So I actually know that I want to loop over the CNT column. So I access directly to the CNT with the iteritems. And I'm not anymore going to specify a column name inside there, but I'm going to use the index of that particular Pandas series. In our case, it's going to be row 1, right? Since, let me say, this is not anymore a rows, otherwise you're going to get distracted. So you are going to access to the particular column, and you return actually the column itself, since it's a Pandas series. And in this situation, again, you get, as the help was suggesting, a tuple containing the index row where you get that particular observation, in this case 872, But now you have iterated not with respect to rows, but with respect to columns. And here I made your life easier since I just consider one single column at a time. In our case, the total count. So this is a major difference that distinguish the two methods. And so now the question is, well, suppose that I want to perform some algebraic operations that involve two or more columns inside our data frame. How can I use those two methods to perform an efficient operation? So, as I said, let's suppose that we want to sum up those two columns that actually describe the temperature in decimal number, and this A temp that actually is also called in the README of the dataset the humidity. So suppose, but regarding actually the physical meaning of the columns, suppose that you want to take a simple algebraic sum of those two columns. So we have actually a data frame that is not huge because we have something like 1,500 rows. So it's not a big data set. And but suppose that you want to sum up those two columns. So the question is, how can I do that? So typically what we do is actually creating a custom method that is gonna sum up the two columns. So we create a method called, let me say, get temperature. And in this case, we're gonna take into account single row and column 1 and column 2. And we return basically the sum of the two columns. So row in position col 1 and row in position col 2. Okay, so once we define this method, we have actually to apply it row-wise, because we want actually to create a new column in our data frame that takes into account the sum of those two. So given our two above methods, iterrows and iteritems, the choice ends up with the iterrows. Why? Because we have to add a new column in our data frame, and that operation is going to be row-wise, applied row-wise. So we're going to perform a simple loop in Pandas using the iterrows, and we actually apply it to the data frame. Okay, and we actually try to create a new column by applying that get temperature method row-wise. So for instance, you can say, well, I'm going to apply row-wise, and I create a new column that I call new col for simplicity. And this is nothing more than the application of the get temperature with respect to each single row, and then the column temp and a temp, as I said before. Okay, so this is our baseline. Okay, we are trying to understand how those methods work. So let's try to see what happens now if we try to run this snippet. Call 1. Let me check why it's not working. Oh, well, yeah, he's right. It's not a string, it's an argument. Here we go. So I got back to my result, and if I try to access to the first 5 rows of this data frame, nothing happens. So if you pay attention here to cell 10, I try to append, I try to create a new column for each single row during the loop operation by adding this sum of these two columns. But at the end, nothing has been shown. This is because actually the operation is done in memory and not in place. And therefore, we have to think about a different strategy in order to use iterrows if we want to append the result in the data frame. And to do so, actually, I'm going to create a new method that I call new method. Sorry for the creativity, but the most important thing is getting straight to the point and understanding the logic behind that. And this new method is gonna basically perform the same operation that we did in cell 10. So I'm gonna just copy and paste here. So basically we have this loop operation for each single row, but I'm not gonna create this in memory, but I want to store the loop results inside a data structure. We can think of a list, a tuple, a dictionary, whatever you like, but possibly it's better to create another data frame inside this new method, and we're going to append the results basically inside that data frame. So I'm going to create a new data, which is nothing more than another pandas data frame that we initialize with the data frame function. And I'm going to pass this data frame, the columns, which is nothing more than the list of data. And therefore, now we have an empty data frame with specific columns that are nothing more than the original columns. And now, every time I'm looping in the rows, I'm gonna append the resulting new column in the new data structure using the append method, obviously. So one might ask, well, I'm following your steps, but why did you append a row instead of a row new column? Well, if you pay attention, I have set up a data frame that has a number of columns equal to the number of columns in the original data frame. And therefore, I'm gonna append all the original columns for each specific example. And then I'm adding in memory a new call here in this line. And therefore, when we append all the row, we're going to append not just the original data, but also the new call one. So once we have done that, we basically return the new data. And that's it. So once we have written this method, we can say, well, we try to apply this new method to the data. So I'm going to take this and apply to the df, to the original df. So let me call this df with the iterrows. Well, it's data here, sorry. So it took time, it took a few seconds to get to the result, but at the end, you got the desired column, okay? Which was the sum of those two distinct columns, temp and datemp. So if you pay attention, it took a little bit to get to the result. And a way to be sure about that is to use the magic function that comes from the IPython library, which is the timeIt function. And since it's a magic function inside the Python, you can access to that with this double percentage symbol, and you write the timeIt. timeIt is actually a library in Python, a built-in library, but you can access directly to it in an easy way using these magic commands. There are thousands of other magic commands. So if you're curious, you can check on the net because there are so many commands available. For the moment, we just need to understand that this command is gonna actually is used to time a particular piece of code that you have written in your base code. So in our case, we want to check how long it takes for this method to be applied on our data frame. And the timeIt is gonna perform a few loops, a few iterations, and then it's gonna return the best time, the minimum time that it took to perform an end-to-end call of that method. So it's taking time, don't worry for that. At the end, we got this result. So it says that it performed a single loop and best of 5. And that particular loop took 3.5 seconds, okay? If you think about, we are taking into account 1,500 rows, which is not a big data set. So if we take 3.52 seconds for 1,500 rows to perform a simple sum, think about having a large data set with millions of records. This operation is gonna blow up your memory. It's not gonna be efficient at all. So we have to think about different strategies that allows us to actually maximize the performance of our base code, but in particular of our operation, which is a simple sum, as I said. And one way that you can do that is actually to use the apply method, the pandas apply method, that is actually going to apply a function along a specific axis, either rows or columns. And as I said at the beginning of this webinar, this function is going to save your life in many situations. And so it's worth that you understand this particular function, since I believe you're going to use it a lot during your personal career, and in particular during your personal coding sessions. So why is so cool, the apply? Well, there are many motivations behind that. I have to say that it's better than iterrows since it uses Cython in the backend, and therefore it has some routines that are maximized to perform some task. And therefore it's worth now that we're going to see how to apply this particular function in our use case. So remember, we have a data frame, okay, that we call df, and we actually want to create a new column based on the sum of those two columns, temp and datemp. So the syntax, if you want to use the apply, goes as follows. You actually apply the function apply to the data frame. And remember, the apply requires an application of a function along a specific axis on the data frame. Which function do we want to apply? Well, we want to sum the two columns. And if you remember, we have built a method called getTemperature. So we want to apply that particular function with the apply method along the column axis. So we want to create a new column, and therefore we are going to apply it column-wise, because we are going to take into account the two columns, the temp and the temp. And the apply actually requires you to apply a function. And one way to perform in Python this operation is to use anonymous function. And anonymous function is, for instance, a lambda function in Python. So you actually apply a lambda for each single row. And here you're going to take the getTemperature function that we defined before, that requires a specific row, in our case X, since we are using an anonymous function here. And then you take the temp and the temp column. And then you specify, as I said before, the axis along which you are applying this particular function. And as I said, we are going to apply it column-wise, so axis equal to 1. And that's it. So this is pretty neat as a function, since it's very compact, nice to read, and in particular, if you pay attention, it didn't require some coding as we did here in the new method. And we can apply actually this function to create a new column using the apply. And this operation is going to create a new column in the original data frame called new call apply. That is nothing more than the application of the getTemperature. Let's try to run it. Did you see that? It took a few seconds, I would say milliseconds, to get to the result. And so I can bet that this method is much more efficient than the iterrows. We know that, but let's try to be more specific, and let's try to use the timeit magic command again. And we are gonna actually check how long it takes to perform this operation using an apply method. It's looping, so it takes time. Okay, so pay attention. Before we add one loop, here we're taking into account 100 loops. So that's why it took so much time to get the result. But that is not the focus. The focus is here. Per loop, it took approximately 19 milliseconds. And if you compare the efficiency with respect to the new method application, it's stunning, right? We are saving a lot of time, and in particular, the difference and the change is dramatic. It's incredibly super efficient apply, as you can see, and therefore this is a confirmation that you should go for the apply method when you want to loop over rows in your data frame. So given that, we have actually missed a particular member of methods that allows you to perform some iteration in your dataset. And in particular, if you pay attention here, we focus on the iterrows and on the iteritems family. But we can also use another member that allows you to perform some, let me say, looping operation inside pandas. And this is called the itertuples. So the itertuples is, as the name suggests, is going to iterate through your data frame with respect to the rows, but now you don't need to access to each single value inside each single cell, but it's gonna take into account a row as a unique object, and that object is a tuple, a Python tuple, and it has been shown that the itertuples increase the efficiency of your base code if used correctly. So I just want to show you that particular case. So I'm going to copy and paste the method that I created before, the new method one. So I'm gonna copy that and paste here. And I call it new method, let me say itertuples, so that we distinguish it from the previous one. And well, let me say like this, that now instead of performing this loop with the iterrows, we're going to use the itertuples. The itertuples is nice because allows you the flexibility to choose to either retain or not the row index. And to do so, you can actually specify the argument index equal to false. That actually allows you to not to retain the index when meanwhile you are looping inside the data frame. So given that, you can actually get this result and store, for instance, in a new call list. Before we actually apply directly to a data frame, now we change our logic and we use an appending strategy. We are appending the results to a list, and therefore here we are going to append the call of the get temperature inside that particular list. Different strategy, obviously, but let's try to see whether this is going to work. Finally, be sure that you change this line, because now we are not appending anymore with respect to a data frame, but we actually create a list and then we call the new data here, and we basically call the new call here. We create a new column, which is nothing more than the new call list that we just created. Well, I guess that this is not necessary, so we can even remove this so that it's much more better, I guess. And that's it. So let's recap a little bit. We are looping using itertuples. As I said, itertuples is a method that allows you to iterate over rows, but you don't access to each single element, but you access to the entire row, and that entire row is described as a tuple. And the nice thing is that you don't need to retain the index. So we set index equal to false. And now we are iterating over each single row and applying the get temperature method to get actually the temperature for that particular row, and we append it to a Python list. And that particular Python list is used to create the new column, okay? Note that the itertuples is so efficient, but it has a cost. The cost is that it doesn't retain with in that particular loop the column's name, which means that you have to actually access to each specific column with a column index. This has from an efficient point of view, it's better than iterrows because it doesn't have to remember the column name, but it has the cost that you have to remember in which index that particular row, that particular column, sorry, was placed. So in our case, we have that temp is placed in column 0, 1, 2, 3, and day temp in column 4. But you have also to take into account that we have an index, an extra index. So basically you have that this column, this is taken as a column. So you have 0, 1, 2, 3. Temp is in position 4 and a temp in position 5. So instead of placing the string here, you're going to place the index, the column index inside that. Okay, so that was pretty lengthy as process, but the most interesting thing is that, well, I can apply this new method itertuples and by passing the original data frame, and I call this df itertuples and check what's going on here. New call. Yeah, sorry, it's not new data, but it's data. Okay, it was flashing as a process. Let's check the consistency of that. We're getting this column, which is 0, 0, 1, 2, 3, 4, and 5. So it looks like we are summing this 0. So I guess it's 5 and 6. Sorry for that. Let's check. Not yet, not even that. Why is that? Let me do like this, because I need to understand with you live what's going on. Let's check. Okay, yeah. Let's try to check it. Okay, so we have in position 0, 1, 2, 3, and 4. So it's 3 and 4 and not 5 and 6. Okay, now we should be back on track. Not add anymore. We can remove it. And finally, we should get to the result. Here we go. Luckily, we got to the result. So, so we got that, but if you pay attention, the velocity was much, much better than the applied one. So in order to check it, as usual, we apply the time it and check whether how long it takes to create this new data frame called df itertuples. Boom. So 100 loops, and look at the outstanding performances, 4.51 milliseconds per loop. What does it mean? It means that we are actually outperforming the apply method with pandas. And therefore, at the end of the day, you have to consider even itertuples when you want to apply such kind of iteration between columns, since the performances are outstanding and they are worth to be noticed. And therefore, I strongly recommend to use itertuples in place of the apply, obviously. But in general, this is my strong suggestion. When you want to actually loop over rows in your data frame, don't use iterrows. Try to use the itertuples, because it's gonna make your base code much more efficient. And therefore, this is your base code, but also your app is gonna benefit from that. Okay, last topic is related to something that it's pretty similar to the apply method, but is related to a family of methods that that goes under the umbrella of the eval method. The eval method is actually a pretty performant class of functions, since they are based on numeric expression library. and therefore they have some C routine in the backend. And they are pretty nice since they allows you to get better performances than the one that you just saw in this webinar. And to do so, as I said, we have already seen a member of this family, and was the query method in the first webinar. Now we are going to try to apply the eval to basically get the sum of two columns, and the syntax is pretty easy. So typically you get your data frame and you apply the eval method in this way, and the eval is gonna take into account a string that you pass inside the function, in our case eval, and that string is evaluated using the numeric expression library in the backend for you by this function. And therefore here what you want to do, you want actually to write in terms of words what you want to perform. So remember, we want to sum the temp and the temp columns. So we are actually gonna write a left-hand side of an identity, placing a string that is nothing more than the sum of two columns. And here you're gonna basically create a new call based on the val method. So this is a simple string that tells the machine to create a new column inside the data frame based on these two columns, the temp and the temp. And this, you want to perform this operation in place. So we are gonna say, well, perform that in place by setting in place equal to true. And if you like, you can actually set this inside a method. Let me say get temperature with the eval, and you actually return the data that you get. So it's going to ingest the data frame, the F. It's going to apply the eval on that data frame, and you pass that particular string, and you return the data frame. Given that, let's try to check whether this operation is going to increase your performances. So I'm going to say df eval, and I'm going to assign to this variable the application of the get temperature eval using the original data frame. It took a few milliseconds, but now let's try to understand whether that operation was good or not. So time it, we are gonna perform this get temperature eval. So if we try to run this cell, what's going on? So it took 100 loops, and again, we are decreasing the time of the to perform that particular operation. We moved with the apply, it took 90 milliseconds per loop. Then we use the itertuples, 4.5 milliseconds. And then look at that. With the eval, you get 2.80 milliseconds per loop using that particular data frame. So at the end of the day, if you want to compare the two extreme cases, namely the iterrows and the eval, that are all used to perform a loop with your data frame, you are moving from actually a 3.52 seconds per loop to an outstanding result of 2.78 milliseconds per loop. And therefore, you get this data frame, the data frame eval that we inspect just for curiosity. We got all every time we got the same result, which is good for us because it's consistent. And well, the take-home message is that we actually need to take seriously into account different methods to perform a loop operations inside Pandas. Since if you try to apply the wrong method in a particular situation, that method is going to blow up your memory and is going to give you worse performances in production for your app or for your basically code. So I see that there is a question to conclude the webinar, and the question goes as follows. You are asking, in case of vectorization, it is better to use the apply or eval. So that's a good question because we haven't spoken about vectorization. So it's worth to mention that Pandas actually is built to perform either loop operation or actually take column-wise operation. And if you decide to take into account the two columns from the original data frame and you want to perform some algebraic operation with those, you can actually use the vectorization that is behind Pandas and perform the same operation. So what does it mean? It means that if you want to say, well, I'm going to create a new column in our data frame called, and I call it new call vectorization, this can be written as df temp in position temp plus df in position a temp. This makes a lot of sense because actually we don't need to take into account strange loop or even strange methods that possibly you don't know. For instance, the eval is not very popular among developers and data analysts and scientists. So if I try to perform vectorization and you try to check how long it took to perform this operation, look at this. We are extremely beyond the milliseconds, and therefore it looks like vectorization is performing much better than the eval, which is de facto the best method to perform looping operation inside Pandas. This is cool, but it has a drawback. This vectorization works pretty well when the dataset is small. So in our case, the dataset is small and everything is smooth. But if you are a data scientist and you are working with tons of data daily, and or possibly you are working with complex data frame, like if you are applying that to NLP, for instance, as an application, possibly vectorization is not gonna help you too much since the operation behind that is quite lengthy and demanding. And in those cases, you have two possibilities, even using the eval as a benchmark or moving to different tools than Pandas, like Dask or Spark, that allows you to parallelize your job. So this was quite a good question from you, and to precise answer to your question, I wouldn't use neither apply or eval because of the motivation that I just gave you. Other question? I guess no. So thank you for the attention. It was a pleasure to speak to you.
Awesome. Well, that's it for today. Thank you, Andrea, for leading this session and this whole series. And of course, thank you to our audience. We hope you enjoyed it. Before we part ways, just a couple of reminders. You will receive the recording of this session as soon as it is available. Please do fill out the end of webinar survey, as your feedback is extremely helpful in understanding what kind of webinars you'd like to see more of from Cloud Academy. And if you missed the previous episodes or you just want to go over something that Andrea explained in one of the previous sessions, you can find all the series on our website, specifically on cloudacademy.com/webinars. And that's it for now. Stay tuned as we're planning other hands-on sessions. So keep an eye out on our webinar page. And thank you again to all of you for being part of this journey. We hope you enjoyed it as much as we did. Again, thank you for joining us, and until next time. Goodbye, everybody.